Ladies and gentlemen, boys and girls, how's it going? How's it going? Hello, hello. Waffle also says hello. He just made a very loud, very inquisitive noise. Also, I forgot to check my hair. I took a shower like an hour ago and I forgot to check my hair. Okay, I think we're fine. We're chilling, Boom. Man, we're getting hype in here, bro. We're getting hype in here. This directly correlates, right? Interesting. I was wondering if it correlated at all. I don't think it does. I thought it correlated with like the volume on my desktop, but I don't think it does. Okay. Bro, Waffle's been such a menace today. He is just like making all the noises. He was like sitting on a chair looking away from me and just meowed out of nowhere. Like just once. I was like, what? Do you need something? Can I help you? Like, I don't know. He's being goofy today. But also, when is he not goofy? Okay. Let's jump right back into it. I don't think I have any announcements besides I think the Discord server is going to be up by Monday. That's my goal. I still need somebody to test it. Make sure that I have the permissions set up correctly. I pretty much just have like one general channel and then one channel for stream, like for my stream announcements. So that's it. But I just want to make sure it's set up correctly before I throw it out there. And I know how to do the permissions in case I need to change anything abruptly. Yeah. So let's go ahead and jump back into this. So we were working on the enemy movement. Yeah. So we got like half of it done. We got it all planned out, and then we got like half of it implemented. I recall. And let's see. Okay, so I might change the music. Just guys, let me know if this is like too crazy. It's definitely like hype, but I don't know if it's too hype for our stream. Our stream's usually pretty chill, but we'll see. Like sometimes I'm like bopping with it, and other times I'm like trying to like collect all my thoughts in my head, and I'm just like, I can't stop bopping, you know? But we have currently, it's checking ahead, and then it's finding the open direction going in a counterclockwise motion, which is down here. And we're logging on what rotation we're exiting. So as long as the count isn't always 0, then we're fine. Or isn't always 3. Isn't always the same number. It should be varying, essentially. As long as it's not always the same number, that's all I care about. Because it's really hard to check if it's actually like finding the right path because it's all real time. But this way, I at least know if there's variance, then it should hypothetically. That's a good sign. It's a good sign. I could do another. I could do like a different test. We'll see. We'll see. Hold on. Just going to start this, and then it's gonna be like, all right. Hold on. What is this? Where is this coming from? 345. All right, just comment this out. Okay, try this again. My nose is like really, really itchy. I cannot stop itching my nose. All right. 1 1 2 2 2, which like theoretically that makes sense, right? But does it? But does it make sense? This is definitely a jam. This is not what we're used to on this stream. It's usually much more chill music than this. But I'm liking it. I'm liking it. I want this enemy. Again, as long as it's not reporting the same number. Oh, actually, hold on. So it hits here, and this is straight ahead, so it's going to look counterclockwise, which is this way, and it sees this way is open. So that's 1. So it should keep going this way. If we do this way, though, then it would go 1. It should still. Ugh. So we did 2 there. Where's it at? It's going 1 1 1 1 1 1 1. No, give me the enemy. Still 1. So this is 2 here. Why? This is 1. I think because it's tilted like this is where it's looking, and then that I think is 1. Like if we put it here, 1 should be. Yep. Okay. All right. So for my limited testing, seems like it should be good. I could. We'd have to have, does check head return anything? Check head returns a Boolean. Check ahead. Well, we do have this global thing. So we could use this and just say distance to obstacle is. All right, we'll do that. I don't really know if that's the best design, but oh well. So do movement times equals distance to obstacle. Divided by 2. Then create a new vector of free space Okay, so we'll call this vector 2, call this avoidance vector. That's going to equal new vector 2 direction of free space. Oh. Okay, so we're going to say vector 2 free space. It's going to equal that. So we're going to do free space dot normalize. So we're going to normalize that so it's just, it has a magnitude of 1. And then you want it to have the magnitude of the scene distance. So times what is that called? What is it called? It's up here somewhere. Circle cast distance. Okay. Then movement plus equals avoidance vector. Why can you not do that? Okay. Can we make this a vector 3? And then I'm just going to do if avoidance vector dot z is not equal to 0. Just debug dot log error. Log error avoidance vector not two-dimensional. Okay. No. There we go. Okay, cool. Look at me throwing errors in here. I don't think I've ever done that before. That is so responsible of me. And then just go ahead and normalize the movement vector. Okay. All right. Let's see. I've been working in NeoVim a lot because I'm doing, I'm like setting up a LAMP stack, doing that kind of project. I almost just did like, I almost just did a :WQ to save and quit. That's what I'm used to doing, bro. Let's just do this whole project in NeoVim. That would be so, no, I couldn't. First of all, I don't know how to even set that up. That's a lot of overhead that I don't really want. It's a lot of work right now that I don't want to put in. It's not worth it for me at this moment, in my opinion. All right. Let's see. Okay. That was interesting. It was very staggered, I should say. Huh. That's pretty smooth. I feel like it was kind of bad the first time, but like, why would it be doing that? Why would it be staggering? Can I get a closer look at it? Yeah, so it's like boom, 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 boom. It's going different directions. You think it's because it's like going on the edge? Can I see what the velocity is when it does this? Okay, so we have negative 29, so it's going negative this way and negative this way, almost exactly. So it's going at like a 90-degree angle, or a 45-degree angle. Southeast, okay, that makes sense. Does it change abruptly? It does. So it turns hard. And that's where you see this. You see 38, negative 11. Why would that be? So then, yeah, now we're getting into the stagger range. Oh. Yeah, it's very, very interesting. The X is like completely inverting. Or like, just like, not inverting, but I mean, it's going from negative to positive. Are we printing these? That's why. Okay, so it's turning, right? I don't necessarily know how to fix that, because what it's doing is let's pull up the paint. What it's doing is we have obstacle here, the flies here. It's saying this is obstructed, so check counterclockwise left. Okay, go here. Okay, now this isn't obstructed, so go here. Now this is obstructed, so now you have to go here. Now this isn't obstructed, go here. Now this isn't obstructed, go here. I think I'm going too harsh. So no. I don't know why it does that. Okay. Okay. So instead of strictly saying go 90 degrees counterclockwise, should move closer to 90 degrees. The closer you get. Right? But how do I solve that? Because I don't think the problem is with this portion. That's like actually, I don't think the problem is with the avoidance vector, you know? I think it's with selecting this, you know? Or maybe it's just too strong. Maybe that's too strong of an avoidance vector. Maybe. So what if I do this? Is that going to do anything whatsoever? I think I just messed this up, didn't I? Oh, I forgot to unpause it. Whoops. Okay. Because there's nothing wrong with that, right? But instead of going back and forth, it should be something more along the lines of it should be something more along the lines of like, hey, this is obstructed and this way is not. Let's move like halfway between them. But also it doesn't matter. Like if the point you're trying to reach is here, this is viable, right? Because then again, you're going to check this and be like, okay, look, that's not. Interesting. What if you always moved halfway between them? Does that work if let's say you're here. You check 90 degrees and then you start going this way. So you're going to end up still probably colliding into it, right? Right, I mean, I guess you would be probably like here, right? And then you do the check. Okay, but now you're getting closer. So instead of moving halfway down the middle, you want to move closer here. Okay, let's document this. So when obstacle barely comes into field of view, is that? I think that's like a common abbreviation, but I could be wrong. When obstacle barely comes into the field of view, should move 45 degrees toward open direction, or halfway. Which would just be like difference of the, we'll say like angle between the two directions, halved and added. I like that's half the angle between the two directions. Then as obstacle comes closer, move closer to completely going to the open direction. Going the open direction. Okay, so I like this. I like this. Mathematically, I don't know how it works, but now I have a different question. So let's say you're here. You have a wall here and here. Your first check is here, doesn't work. Second check is there, doesn't work. Third check is here. You obviously, like looking at this, you know you want to go this way. Even if there's something here, you theoretically want to go this way. How do I reason with that? Because at this point, you're going to go this way, right? And you're going to end up here. And you're going to do the same check. And you're literally just going to keep hitting this forever. like you're just going to keep hitting it forever. And so then does this, so if you go here, and then you're now doing this check, saying no. So then you do this check, and yes. So I think you would actually end up bouncing back and forth between these two until you make it out of here. Let me see this one. Because I don't think I actually looked at this. It's very bouncy. It's very, very bouncy. Okay. So that's what happens when I took the divided by 2 away. But now what if I divided by 4? So it seemed to get worse when I divided it, when I didn't have divided. When that number was bigger, it seemed to be worse. So let's make it smaller and see what happens. theoretically, that's making the margin of what's like moving smaller, right? Theoretic. No, it's just giving more basis to the. It's giving more power to the avoidance, is what it's doing. Didn't seem to be any better. So if we don't touch it at all, if we don't. Oh, that's giving entirely less. Yeah, so I guess if we change it to 0, we'd be doing the same thing as making it really, really small. Obviously, 0 is the smallest. But what that does is it that's going to make it so that way if it needs to change direction, it only worries about direction and not the target at all. Very interesting. Much less definitely much less. Okay, you know, let's turn the rounds back on. Let's see what happens. I'm curious to see what this looks like on a grand scheme, on a big level. It's not bad. I don't hate it. They're moving pretty. Oh, okay. These guys have some issues. Okay. See, okay, what's the problem here? Shouldn't it just be completely going this way, though? So there's still some issues. And, like, yeah, that's not really a big deal. Like, it still gets out of there eventually. And for the most part, they do fine. Yeah, it's when we get stuck up against that. Quite the music. Quite the music for this. Yeah, so these are the issues. I feel like I have to fix that. It's the same thing, is it not? Although I don't know why it's like on top of it and doing that. So like if I do this, turn this guy back on, and then just put him like right there, we'll probably see it happen. Is my guess. Bro, I'm getting sauced by this guy. I don't know. Yeah, because it's just like I can't really recreate it. It only happens when they get like hit by something else. It's when two of them are crossing right here, and one of them tries to go into this, and then they just and spazzes out. I really don't know. Why? Like, cause, so I get why it does it at some points, right? Because again, it's saying like obstacle. Okay, try and go here. Can't go this way. Okay, now I can go this way. But so it's like you're getting far enough away and then not far enough, and then you're going back and forth and back and forth and back and forth. And I guess it's the same problem. I guess because it's just like my way is so like this is so all or nothing. Because you're like whatever point you find, you're pretty much full course changing direction towards that. Because the avoidance vector becomes whatever this new space is, and then that, and then all you do is add the avoidance vector to the movement, which becomes nothing, which is nothing. So it's literally is all or nothing. So I want to kind of like interpolate it, right? Pretty sure interpolating is the right word. So I want to be able to make a vector interpolate between 2 points. Let's see. So I'm just trying to look at some stuff here, make sure I know what I'm doing. So we start out with a point, want to end up at a point, and then we have a time or we want something between like 0 and 1. Essentially, this is how like the unity interpolate function works too. You have a start and an end, and then because it's just going to be let's try and work this. Let's try and math this out. So we have, oh, hold on. All right, so we got that right. We got our axes. And then let's say point A is here and B is here. Not the greatest, but anyways. So that's angle 1. This is angle 2. Yeah, which makes sense. This is the original path. And then we want to slowly move towards this over time. Because let's say our obstacle is like this, right? So as we get closer, we want to start here and then go in between there. I don't know how I would get this like starting vector. But A is just like X and Y, right? And then B is just like X1, Y1. If you average both of these, trying to think of like a way to figure this out. I guess, I mean, we could try it doing this. This isn't going to be the most, like, the best math in the world, but not the most scientific approach, but I just want to, I'm curious about something. Like, these lines aren't even straight. I'm literally, like, I'm not even making these lines straight. That's how good this is. That's a horrendous line, bro. Not a very good graph. Okay. Let's do this and let's use this blue here. Well, let's use gray for our axes because it's not clear anymore where the axes are. Okay, so those are axes. Point A can be, I don't know why this is blue, but that's fine. Point A will be here. Point B will be here. So now we have A, I know this is backwards, I didn't do this right at all, but A will do -1, because I want a negative in here too. 1, 2, 3, 4, so -1, 4. B is 1, 2, 3, 4, 5, 6. 6, 1. So theoretically, this should be, add them together is 5. 5 by 2 is 2.5. 2.5. That's crazy. That's actually wild. All right, let's see. So we have this and this, which is a right angle. How did I manage that? And then 2.5 and 2.5 is here. Yeah, so if you average the what are x and y called in like a coordinate? Each x and y is, I guess if you just like, if you average the coordinates of 2 points, let's say 2 vectors, will you get a vector with an angle directly in the middle of them? Let's see what ChatGPT has to say to this. Averaging the coordinates of 2 vectors does not necessarily produce a vector with an angle directly in the middle of them. The result depends on whether the vectors have the same magnitude and dimensionality of the space. Oh, interesting. Did these have the same magnitude? It's probably close enough to where you can't tell. But this has a magnitude of what? That's 4. And this has a magnitude of 6. So it's pretty close. So this would slightly be closer to this, which I cannot tell if that's true or not. But okay, so yeah, how do you bisect the angle? How do you bisect an angle mathematically? So to mathematically bisect an angle, you need to compute a vector that points in the direction of the angular bisector. So you just normalize them, add them, and then normalize the result. And then adding the normalized vectors effectively computes the vector in an angular bisector direction because it weighs both vectors equally. Yeah, so I mean, if you, like, roughly, if you normalize this, it's like, I don't want them. It's like here, and then like here. So yeah, it's pretty close. Okay, so that's how you actually do it. So you would have to do, so S would equal, let's get back to white for this. Why is this getting so mathy today? This is ridiculous. So S is going to equal A normalized plus B normalized, and then take this and normalize it. That makes sense. Makes sense, I guess. Let's actually check the internet, because that was ChatGPT. I don't really know how accurate that is. How to bisect an angle mathematically. Math open reference. That's got to be a good one, right? Let's pull us over. Let's pull us over. QA is congruent to QB. AC is congruent to BC. What? Oh, QA, QB, QC, QB, QAC, and QBC are congruent. See, that's not at all what I wanted. It's not at all what I was looking for. Oh, no, I want to bisect two vectors. You calculate the vector. No, hold on. So Stack Overflow says to find a bisector of two vectors in general. Oh, interesting. Yeah, you could do that, couldn't you? Because if you had one angle that was at... Yeah. But you have to be careful because... So you have two different points. This angle is what? Like 30? And this one's... 135. So you get the average, and that's 165 divided by 2, which is approximately 82. So it's like there, which looks about right. Can you get... Let's see. Vector 2. Can you get the angle? Oh, I don't need to get the angle of it. I don't need to get the angle, but unsigned angle in degrees between two vectors. That's the problem, though, is that if you use sine, cosine, tangent, it's going to give you... No, it'll give you degrees, won't it? Okay, let's hold on. Let's write this in here. Right. So let's do like we'll do a test one, and we'll just do bro, I literally just want... Oh my gosh. Thank you. Okay. All right, so let's see. We have this. Yeah, let's do this. So our first angle is going to be our first vector is going to be 2, 1, and then we're going to have a second vector that's going to be -1, 1. So that's 135, and that's 30. The split angle between them should be 82.5. Pretty sure. Well, my math is correct. So we're going to have -1, 1. And then B is going to be 2, 1. Then we're going to go ahead and debug .log. Well, no. Is there tangent? Math F tan. Math F, I think tan 2 is. What's radians to degrees? What is this? Sorry, I'm over here. Radians to degrees, you just do radians times that. Okay, so this is just 180 degrees over pi. Yeah, just 180 over pi is all it is. Or yeah, it's 180 over pi. Yeah. So let's do float angle A is going to equal math F dot tangent of a dot y divided by a dot x. Hold on. Let me make sure I'm mathing this. I just have to make sure. The angle is it's opposite over across, so it's x or y over x. Yeah, my bad. Yeah, y over x. Yeah, that's right. Okay. And then we need angle B is going to equal math F dot. Let's just go ahead and do this, but it's going to be B and B. Okay, now we're going to debug dot log A is angle A, and we can just copy this, paste this, but that'll be B and that'll be B. And then debug.log middle it'll be angle A plus angle B divided by 2. And make sure that's parenthesized. Okay. Let's go ahead and just fire this up real quick. Make sure that this is working generally the way I think it is. Should be. Okay. So A is this. Oh, hold on. I don't want to look at radians. That's just complicated. Times math f dot radians to degrees. Go ahead and copy this, paste that in there. Yeah, okay. Now we're good to go. All right, once again, let's see. So we have negative 90, essentially, and 30, essentially. Middle is negative 28. That's because it's not negative 90. Negative 90? Am I dumb? No. What? And negative 90 is here and there. And halfway between that is... Well, wait, no, because that's 100 and... What's that, 120? 120 divided by 2 is 60, so... 30 minus 60. So yeah, that's right. I don't know why A is negative 90, though. Yeah, negative 1 is right here, right? I am lost. Why is this? Negative 90? I think negative 90 would be 0, negative 1. Let's see what this is. Yeah, not possible. Am I like arctan of I'm so lost. I'm so lost right now. I'm literally looking up a picture of the unit circle. I'm confusing myself beyond comparison. Yeah, 3 pi over 4. Is -1. So arctan of, I did what? 1 or -1. Guys, I'm so confused. So wildly confused. My math is not mathing right now. Okay, what if I did -2, 1? Then what am I gonna get? Isn't making a lot of sense. Because you're telling me that it's there and there now. Even though I know it's that divided by that. So it's, I know it's y divided by x. And the x is 2 and the y is 1. I'm just trying to make sure that I'm not like going insane. Yeah, because so if you do like the tangent of 2, the tangent of 2 wait, no. If you do the tangent of the tangent of 30 degrees. No, I'm really confused now. Okay, so if you take the tangent of 30 degrees, it's just over 0.5. The tangent of 60 degrees, it's 1.7. Take the tangent of 45 degrees, and it's 1. Because the tangent of 45 degrees that's 1, 1. So that's why. So if you take the tangent of 135 degrees, it's -1. Which is also, so I guess I think what's happening is so tangent, this quadrant and this quadrant have the same sign, and this quadrant and this quadrant have the same sign. These are both negative and these are both positive. So doing tangent of -1 could mean you're here or here, because this would be 1 and -1. And this would be -45 though, not -90. So I still don't know how we got to -90. I'm still confused on how we got to -90. I think I'm just being like really, really dumb. But I still don't know how we got to -90. Let's do this. Don't sign in, please. Oh my gosh, I always forget to stop the game. Every single time. Okay, it's fine. It's all good. It's all good. Sir, I don't know why it's 90. Why is it 90? No, it's not 90. I'm doing the tangent of -1, 1. And the tangent of -1, 1. Or tangent of 1, 1. Like this isn't right, and I'm really confused as to why it's not right. Like tangent of 1. Wait, hold on. Wait. No, I'm confused. So I'm in radian mode now, which is what this is in. And so, oh, I think I'm just like tangent of 1 equals that, but multiply it by pi, or no. Multiply it by 180 divided by pi, and it's 90, even though it's not. So if we do this, it's going to change to the right answer. Supposedly. Maybe. Oh, bro, I just used tan instead of arctan for like an hour, half an hour, 20 minutes. Too long. That's ridiculous. I'm literally frying my brain. Just use tan instead of arctan. That's so... I cannot believe I did that. Oh. Oh, did I just kill the music? I did just kill the music. My bad, guys. My bad. Killed the music. Closed the wrong tab. That's on me. Do you want to say hello to the stream, Waffle? Yeah. No? Okay. Waffle, say hello to the stream. Oh, Waffle, you made the camera mess up. Say hello, stream. There you go. Waffle has said hello to the stream. Of course, it's blurry now, isn't it? It looks blurry. I can't tell if it's blurry. I think it is, but I think it'll be okay. All right, music is back from the dead. All right, hold on. I need to look at something. I need to look at something. Oh, bro, I'm so dumb. The tangent of an angle is the opposite over the adjacent side. Oh, why did I open up command prompt? Okay, so for the last 20 minutes, I've been doing tangent of y over x equals angle, but it's the tangent of the angle equals y over x. Good one, good one, good one. Okay. Smooth, smooth, smooth. What's the random in Unity? I never remember what it is. So it's random class and then Wait, is there not an on unit circle? All right, whatever. It doesn't matter. Yeah, actually do this equals random dot. I have to do unit engine dot random dot on. Bro, what you mean? Oh, inside. Okay. And then do this. This. And then do debug dot draw line. Start is going to be vector 3 dot 0, and then new vector 3. Actually, could we just make these vector 3s? Yep. Okay, that's fine. A color is color dot white, and duration is going to be 10 seconds. Ooh, what's wrong with this? It's capital C color dot. Okay. So, whoops, copy that. Whoops, paste that. Paste that. And then you could do float angle C equals this. Then vector 3 C is going to equal new vector 3, and it would be I think it would be math F. I think it's a cosine angle C. except for this is... Okay. Pretty sure this is right, but we'll see. This is like so silly. Private draw lines. Let's avoid. And then actually we'll make this I enumerator. What? Oh, okay. Then return yield. Nope, nope. Didn't want that. There we go. And then this will be like, actually do 3 seconds and then make these 3. And then every fixed update, just call start coroutine. See what this dot is. like there's no reason for me to write that. What's up with this? Oh, I got you. All right, let's see. Let's see. Okay. It's not gonna actually print anything, so there's a reason for this to be here. Oh, these are gonna be really small. Let's multiply these by 10. Yeah. They'll just be a little bit larger. Just make the magnitude higher. Okay. So I assume it's not going to do anything. Yes, it is. Okay. Oh, I forgot to do one other thing. Change this color to blue. Okay. And now we'll be able to know which one's splitting them. There's a good chance that I mix up the sine and the cosine, or that's not even the right way to use sine and cosine, because apparently I don't know how to do that. What? Where is the blue line? The blue line doesn't show up very often. And why does it do it so fast? I don't even know if this is good or not. It's because it's calling it every single second, so it's just glitching it out. Two, three, yeah, yep. Uh, so what I need to do is say like float. Private. I really don't want this to be this complicated. Private float timer. Then do this. Okay. This, I think, should work. Wait, I don't want the coroutine anymore. There probably is a way to do it so that way it works like that, but... Or maybe I just don't know how to use coroutines, which is actually definitely what it is. I definitely don't know how to use coroutines. I do to some extent, but I feel like I don't use them to their fullest capability. And also that I'm just not super well versed on them. Alright, let's start this. Okay. 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 So I'm noticing something here. Where is the blue line? So the first time I did it, I had all of them white and they all showed up. But since then, the blue one only shows up occasionally. Is this literally just to do with the colors, or is it just I just got lucky that first time? Appears that I just got lucky the first time. Okay. Let's do a couple things. Okay, but see, this is why I'm doing this, because I want to make sure that these small parts work. And I know that I should probably know how to do this, and I probably should have been able to do this in the span of 2 hours. But, oh well. Womp womp, as they say. And that should get rid of the spam logs that are in there right now. Should Should probably make a habit of taking those out like as soon as I don't need them anymore, so I don't have to go track them down when I actually want to see something useful, and not just 1 1 1 1 2 2 2 2 2 just everywhere in my logs. But okay. So no, I'm not using them right. All right, so well, let's just. So we have an angle, right? And we want the x and y values for it. And I know that the sine of an angle is equal to y over the hypotenuse. And since all of these angles are normalized, or all of these are normalized, the hypotenuse is always 1, which means the sine of the angle equals y, and the cosine of the angle equals x. Great writing, isn't it? So, isn't that what I'm doing? No, I'm not. I decided to use the wrong things. Really just can't get this right, can I? See, I know what things are. I just get a little confused sometimes. I just get a little tiny little itty bit confused. And it just causes really big issues because I build everything upon these fundamentals, and then I was just a little bit wrong on the fundamentals, so everything is just a lot bit wrong. That's fine. So now we should have 3 lines that are not at all split. Not even close. So we definitely need to make this blue, right? My guess is this has to do with the positive and negative angles. Okay, so we have. Oh gosh, these are so small. But anyways, -3, so that's this one. And then -6, -2. So I feel like if this was, then it would be fine. Okay, so yeah, I feel like if that one was yoinked over, that'd be fine. Okay, that's not even close. That's not even close. That's just absurdly not close. That's maybe no. All right, so this is just blatantly wrong. Yeah, I guess this has to do with this is sort of. What's the C sharp? So there's C sharp math class, right? What is A-tan doing here? Return the angle whose tangent is a specified number. Between negative pi and a half and positive pi and a half. Oh, wait, bro. Wait. The one that I was talking about earlier, I'm so dumb. Because that's... This is the goated way to do it. Right? This... AC is just the unit vector for QR, and BC is just the unit vector for QP. Bro, you literally do just add them. Oh my gosh. Okay, so we have A, we have B. Vector 3C is going to be A normalized plus B normalized. And then normalize these two. Bro, I was right. ChatGPT was right. And then I tried to get fancy with it. I tried to get jiggy with it, and it did not work. All right, let's see. Let's see this now. I'm so confident this is going to work. And I'm so mad that I just wasted the last hour of my life doing things that was just completely irrelevant. Boom. Split evenly. Boom. Split evenly. Boom, split evenly. How did they manage to do that? And then we can also do is instead of printing these, we can say, all right, look, if oh, do I got it. You don't even have to do this. Let's just introduce more error into it, right? So keep it like this. Do this. Make an angle C. Lowercase c and lowercase c. Then you do if angle A minus angle C you want the difference between these two. That's C because that's A and that's... No. That's A. That's C. And that's B. So yeah, you want A minus C to be equal to C minus B. Absolute value of each. Okay. So do that. Mathf dot absolute value. Doesn't like this. What? Oh, yeah. So that minus identical except should be B instead. Is greater than, I don't know, 0.01. Debug dot log. And then also you want to absolute value this too. Okay, so what this is doing is it's saying is the difference between A and C and the difference between B and C close enough to 0, right? That is it close enough to 0? So it should be within 0.01 of 0. So they should be within 0.01 of each other. If not, debug all those, or just log all those. So save this, go back here, and now we should have no logs coming in here. Because I mean, you can tell that they're pretty much split when you do it on screen, but you can't be 100% sure. This is what you can be 100% sure. Bro, what you... Oh, so the first one was? I wonder what it was. I wonder what the difference was between it. Let's see. Let's see what this gets us. And then we'll probably wrap this up as long as this is returning like no errors. 0.5. Okay, so half a degree difference between the two. Not my main concern. It's such a trivial part of this. Like, it's not trivial, but like this is the very, very first thing we need to do. 1 degree difference. -1 degree difference. Not even 0.1 degree difference. 1.5. Okay. I mean, it's pretty strange that that's 2 degrees. And again, it's not the end of the world. 2 degrees is not going to mean anything in all this pathfinding. I don't need it to be exact. But I'm just curious why it's not exact. Because we're... Yeah, that one was -2 almost. Because we're taking A, we're taking B. We're normalizing both of them. And we're even normalizing C as well. I don't know. But, all right, guys. I'm going to go ahead and end the stream here. Hopefully Monday I should have Discord up and running. And then maybe next Wednesday or the following Monday, we'll stream some games. Some playing games, not making games. Switch it up a little bit. But thanks, guys, for tuning in. Make sure you guys check out the YouTube channel. If you guys want to see any of the past VODs, any of the more interesting ones, because it's literally just me not knowing how to do math. But if you want to see more of me messing up, also go check out the YouTube channel. And thanks for stopping in, guys. Have a good week.